Hello, Kent Beck here. I'm a programmer at Facebook, and I want to talk to you today about making big transitions in small, safe steps. This is a theme that's been running through my career for 20 years probably, figuring out how to take the big jobs that we try to do in programming and turn them into smaller and smaller feedback loops. But it's a question that's come into sharp focus with my work at Facebook because all the transitions that we make are big transitions, and it's the tension that I'm about to describe about how big a step do you want to take is especially evident. The origins of my careful study of this issue of how big a step to take goes back probably 7 or 8 years. I was invited to sit on a panel celebrating the 25th anniversary of the publication of Structured Design by Jordan and Constantine. This is the book that introduced the phrases coupling and cohesion, the concepts of coupling and cohesion to the world. And because I was going to be on a panel, I figured I should read the book. I'd had it as a college text, but of course that meant I hadn't read it. So I went and reread it and realized that the things that they were talking about back then were exactly the same dilemmas that confronted software engineers today. How do you break big systems into small pieces so that the small pieces don't have to interact with each other so that you can continue to make changes? And their focus was on coupling and cohesion as measures of how isolated the pieces were from each other. When I was on that panel, I thought, I want to bring this message, these ideas to the programming community, because many of those ideas were really lost or attenuated over time. So at that point, I started what I called the Responsive Design Project. And this has nothing to do with Facebook. This was 7 years ago, that I thought I'm going to sit down and really think about software design and think about how to communicate the ideas from Jordan and Constantine to my community in a contemporary way. I mean, back then one of the discussions was about assembly language versus higher level languages, and nobody much cares about that discussion these days, except people who are squeezing the last ounce of performance out of systems. But many of the themes were exactly right on. Now, as I said, their focus was on coupling and cohesion as measures of how isolated the parts of the system were from each other at a given moment in time. As I began studying design, I sort of already knew it, but it became clear to me that just as important as how isolated the parts of the system are from each other in space, conceptual space, at a moment in time, is how isolated the system is from itself at different moments in time. So on one axis you have the structure of the system, and just as important, on another axis you have the structure of the system over time. And that's when I began playing with ideas about, well, how do you make changes over time? I mean, I'd taken it as a given for some time that that systems were always going to change, the requirements were never known up front, that the presence of the system itself created changes to the requirements, so it was futile to try and nail down the requirements. So the needs of the system would change over time, and the understanding of the developers what it meant to design a good system would also change over time. So I'd taken that as a given, but I hadn't thought about this question about how big should the steps be. Now, I think naturally I gravitated towards making changes in smaller steps, and the kind of communities that I was in, a small talk community, and then a patterns community, and extreme programming, all tended to gravitate towards making changes in smaller steps. But I hadn't ever done a thorough study to say, well, how big should the steps be? How do you figure out which steps to take? And so on. Here's the basic conundrum. You put a system into production, and before it's deployed, life is good. You can program as fast as you want. There aren't a lot of distractions. But as soon as the system is deployed, everything goes crazy. And you spend all of your time trying to just keep the system running. And at the same time, always to get a system deployed, you have to cut scope ruthlessly. So all of the scope that was deferred, we'll get to that, don't worry, all that scope is piling up as you get closer to deployment. And then as soon as you're deployed, the demands for the deferred requirements pop up to the surface. Yeah, how are you going to do this? Now, you said you would do this as soon as you were deployed. Now I want, the next feature, except you're running around trying to keep the system up and understanding the complicated behavior and how things are linked together that you never realized. And that's a really, really tough spot to be in. To do a good job of operating the system, you need to pay your full attention to that. To do a good job of developing the system further, it seems like you need to pay full attention to that, and you only have one set of attention. So how do you get out of this dilemma? Here's the dynamics of the situation as I see it. The tendency, having gone through one of these cycles or more than one of these cycles, the tendency is to look at this and say, well, as soon as we go into production, things get crazy. So what we're going to do is we're going to pack more functionality into that first deployment. The first thing that we really get out there, we'll put more stuff in it because we know how fast we were at developing before we deployed, and we want to take advantage of that as long as possible. The more scope there is in a deployment, though, the greater the chances are for some kind of unanticipated consequences. So then what do? Well, you got the fire drill now. Oh my goodness, the system's falling over. What do we do about it? And it takes you longer and longer to do it. The stress level goes up. The demands for more scope happen further. And so the next time you go to plan a deployment, it's very sensible to say, this is not going to happen to us again. We're going to pack even more scope into the next deployment. But that just means that there's more things that could go wrong, and the more things that go wrong, the longer you're in this limbo state where you can't confidently operate the system and you can't confidently develop, and nobody wants to be there. But driving this loop this way is not a way out of that. On the other hand, it's really easy to blame yourself and say, if only I was a better programmer, if only I, then you would be able to break this and have a deployment that just went really smoothly, and then if on Friday and on Monday, you'd start developing the next thing. This kind of summarizes a statement I've heard from many programmers many times. We could avoid that limbo, that not quite confident deployment and certainly no confident development if we just stopped creating those problems in the first place. And so, ever more elaborate review processes, ever more elaborate software development processes, bigger tools, all kinds of stuff. Here's the thing that I don't understand about this. There's this assumption that somehow you could anticipate the problems, exactly the problems that are impossible to anticipate. We never expected that latency coast to coast would cause these kinds of issues. We never expected the users to use this particular feature in this way. So exactly the problems that come up early in deployment are the problems that there was no way to avoid because you couldn't figure it out. And that's the head scratcher. So what do you do to get out of this situation? How do you avoid that limbo of we can't really operate what we have and we can't develop it any further? Here's the good news. The feedback loop is just like laws of physics. It's just, there's no way of creating a different loop. Scope creates uncertainty. Uncertainty takes time. That's all there is to it. But every positive feedback loop that's killing you always contains the seeds of its own solution. Rather than drive it in a positive direction, you can begin driving it in the opposite direction and get your problems smaller and smaller. Now, it can be a real challenge when you're in the middle of a pile of bug reports as high as your eyeballs to step back and see that you're in one of these loops. I'm not saying it's easy to identify, but once you see what the loop is, you always have the option of driving it the other direction. So remember I said Jordan and Constantine talked about the structure of the system at a moment in time, and I started looking at the structure of the system over time. And that's how I came to this formulation. Like, this is what I want to study. What if we took that feedback loop, took as our goal that we want to be in production and effective at further development? We know that driving the loop the other way leads to a situation where we have less confidence in production and less confidence in further development. So what if we drive the loop the other way? What if we begin by making the time slices smaller? So rather than saying, well, let's instead of going from 2 months to 4 months worth of stuff before we first deploy, what if we went from 2 months to 1 month? Well, that means that we'll only be able to handle half the scope that we thought we could. Now that is a key moment, is recognizing that a smaller slice necessarily implies a smaller amount of scope. If you miss that, then you're in a different positive feedback loop, and that's outside the scope of this presentation. But let's say we're going to have half the time, half the scope. What that means is you have less uncertainty. Fewer things to go wrong. The cross product of all the features and all the other features that could interact in wild and crazy ways gets much, much smaller. And so you get through that limbo state even quicker. And then the next step, and this is what I've been doing as research and applying at Facebook for the past year or so, is if we can go from 2 months to 1 month, could we go from 1 month to 2 weeks, and 2 weeks to 1 week, to a day, to an hour? How small really can we take this feedback loop? I'm not the only person working on things like this. The people doing continuous deployment have been pushing the boundaries of what's possible in terms of the minimum delta T of the feedback loop for several years now, and there's some fantastic ideas there. On the general theme of reducing the duration of feedback loops, I have another talk called Software G-Forces that you can find out on the interwebs, various places, that talks about this in a larger context. What I'm talking about today is, in the rest of the talk now, is really the technical details of how do you achieve small, safe steps in very large chaotic systems. The objection to driving that loop to smaller and smaller timescales is always, this is just going to be so expensive. Every release takes us 2 weeks, and now you're saying we should do a release every week, and everyone takes 2 weeks. That's just crazy. There's no way that can work. Well, maybe going from 2 months to 1 week is too big a step. But the question is, this is going to be expensive in the sense that you have to pay for each cycle. Every time you go around that cycle, it costs some money, some time, some attention. But what are we comparing it to? I remember I gave a talk early. This was early in the XP days in Denmark, and so iterative this and small feedback loops and all day long, refactoring and so on. And at the end of the day, a hand went up in the front, and I said, yes, what's your question? He said, wouldn't it just be easier to do it right the first time? And I thought, yeah, it would be much easier to do it right the first time. If that's the alternative, if you're saying, well, here's tight iteration on one side, and here's, well, you just do it and it works, if there's no contest. Just do it and it works, wins every time, because you don't have to pay the cost of all these stupid little iterations. But all those iterations aren't expensive. They're expensive compared to this fantasy, but are they expensive compared to living in limbo? Unconfident deployment and unconfident development. How much does that cost if you're there? Periodic disasters. What's the expected value of those disasters? Well, humans aren't very good at estimating the cost of infrequent events. So it's hard to come to a numerical answer. But after a few disasters, and then understanding that it is possible always to slice time finer and finer by working in safe steps, it's possible to get at least an intuition that says, hey, maybe if we were taking these small steps, it really would be cheaper than the expected value of taking larger steps and then having these blow-ups from time to time. And here's how it works. The cost of each iteration is not fixed. So let's say the area of this rectangle is like the total cost of the system or something like that. That's how much we have to invest to develop it. And every change is expensive, so we want to have the number of changes be as small as possible. Now, the first thing that happens when you start making more changes is the cost goes up. How is that progress? Except now, let's say instead of deploying once every 6 months, you deploy every month. Well, the activities that were okay to do manually every 6 months, if you do them every month, you get annoyed. You get frustrated. You have better things to do, so you start automating. Over time, because you deploy much more frequently, the cost of changes goes down, and the overall cost of the system, in my experience, actually decreases. But I present this as one set of changes, but in fact, it's an endless cycle. It's always possible to make it cheaper to the overhead of one iteration through that cycle. It's always possible to reduce that cost, the number of errors, the consequences of error, the amount of time and attention required by people, all that. If you make that a goal, that's going to be cheap, the cost of that's just going to keep coming down and down and down, which enables you then to shrink the time cycle even further. And the smaller the time cycle gets, the more practice you get, the more frustrated you get with the things that are expensive. The more you optimize, the cost goes down and the time cycle can shrink again. So, enough about the theory. I'm going to talk about applying big changes in small, safe steps in 3 different domains. In the domain of making data changes, code changes, and system architecture changes. There's some themes that really come out of every single one. You'll see the pictures look really quite similar in every case. First is safety first. The expensive changes you make are you make a change, something's broken, and now you have to go debug it and find out what went wrong. If you can avoid that moment of, oh, what did I do? I don't think I changed anything. If you can avoid that, you can spend more of your time making forward progress. So, safety first. It seems like that's just going to be too expensive, but with enough practice, turns out it doesn't have to be. So, safe steps, isolating change first. If I need to make a change in many parts of the system, I'm better off making a smaller change that isolates the part that I really have to change in one spot and then making that one change. Now, it seems like overhead and it's going to be expensive, but this is another one of these tactics that pays off in the end. And the third thing that's going to come through is parallel implementations. The key to making big changes in small, safe steps is being willing to have 2 implementations of the same functionality at the same time, to learn to live with the old way and the new way. Well, we're going to come in and over a weekend, we're going to convert all the data from the old system to the new system. That over a weekend, that's just like sets off warning bells for me. The sirens, the flashing lights, it just never works. However attractive it is to keep trying it. So here's the first example. Let's say we have 3 clients all using the same data store. And we discover that data store just isn't going to be good enough anymore for whatever reason. This is like a daily business at Facebook. Because we operate at such ridiculous scale, which is a big part of the fun of working there, nothing off the shelf works. And even the custom things that we build for ourselves frequently run out of capacity. So we're storing data in one way and we say, this just isn't going to work anymore, so we need to store it some other way. So, step 1 is to isolate the change. I don't want to go and make a transformation in 3 different places in the system that says, oh, you used to call here, go call here instead. So I'm going to create some kind of little bottleneck. It could be as simple as just a function, or in the case of the big data migrations of Facebook, an object. And none of the clients are going to be able to know how that object accesses its data. They'll have an interface that's more abstract. And once I have that in place, then I can start replacing direct fetches and stores of data to use this little bottleneck object that I just created. Now, that bottleneck object is not a big, hairy, complicated thing, especially at first. I look at the examples of how the code is actually accessing the data, and I just abstract it a little bit so I can call that instead of accessing data directly. So now I'm calling through that bottleneck. So that's a safe step. I've introduced lots more complexity. It's just one more step in between. And then I can change the next one. And I can let the system settle down as long as I need to in between these changes. Now, if you get practiced at it, you can actually do these pretty quickly. But as long as you're at all lacking in confidence that something's going to work, back off, slow down. Safety's more important as a way of getting to speed. Okay, so now we've converted all of our accesses to the old data store to pass through this one bottleneck. Now we can implement a very simple version of the new data store. And immediately what we begin doing is writing data to both stores at the same time. Now, especially say you're bringing up a new database, you can throttle that up and down depending. Let me give a 0.1% of the traffic to the new data store, and we'll see how it reacts. Now, nobody's reading from the new data store, so if something goes wrong at this point, you can just start the process over again. You have a level of safety. But over time, you'll gradually ramp up so that everything that gets written to the old data store gets written to the new data store too. And that's a kind of a milestone in this transition, because you know that no data is going to change in the old store that isn't also going to change in the new store. And now you can begin the process of bulk migration. So bulk migration, I'm just going to go through all of the old data, and we have data, most of our data sets change infrequently. It's mostly read and relatively infrequent writes. So we can go through all the historical data, every status update I've ever made. I'm not changing those things. So there's not really time pressure. I can copy those over from the old data store to the new data store one at a time, a few at a time. Once I get the hang of it, I can have a whole army of servers doing these kind of transitions. At the same time, we're still duplicating all the writes. So new data is going to the new store as well as the old store, and gradually we're filling up history until the new data store has all the information that the old data store had. At this point, we should have exactly the same data in both stores. And that's the point at which we can begin double reading. So we were double writing for a while, did a bulk migration. Now we're double reading, and this little bottleneck object is a great place to compare the results from the old data store and the new data store. And we can find out if there are any differences between the two. So, sounds good. At some point, the number of deltas are small enough that we're confident turning on the new data store as the system of record. As long as we aren't completely confident, we can continue writing to the old data store. But as soon as we're sure that the new data store is going to work just fine, we can get rid of it and have a big party, because it's fun shutting big systems off for sure. Recommissioning the servers and have a good time. And now we've made a gigantic transformation. Unfortunately, I can't quote you exact numbers here, but a lot of data could take months to do one of these transformations, but it happened in small, safe steps. So it's a big transformation. It happened in small, safe steps, and at every step we were sure that what we were doing wasn't going to cause any harm, and we were able to look at the immediate consequences of the change we make and discover if we're right or not. If we're wrong, we're safe to back up and try it again based on what we learned. So, the tips here: isolate data access first. Don't go making the change in 3 different places. Don't go make a complicated change in 3 different places. Make a simple change in 3 different places. So now you have one place to make the more complicated change. Next, set up double write before you're doing the bulk migration. This happened to us in the messaging system that I'm working on now. You get into the Zeno's paradox. Okay, we're going to bulk migrate all of the data, and you get finished, and it takes you a week to do it. So now you have to bulk migrate a week's worth of data, and you get finished with that, and it takes you a day. And now you have to bulk migrate a day's. You never actually get there. That's the Zeno's paradox. Setting a double writing first gives you a line that says bulk migration will be done when everything before November 12th has been moved over. And finally, dirty data is just a killer. That bulk migration process and even getting double writing to work, you'll discover things about your data that will appall you. And I've done exactly this kind of process, not just at Facebook. I've done it on financial systems handling substantial sums of money, and I was appalled also. So that's just something that's going to happen. Be prepared for not knowing how long that process is going to take. Okay. Switching now to code. This is say a lower level example. Let's say we have 3 places that we use one kind of collection class, for example. So all 3 of these places, they all create this collection class, and we want to use a different collection class. So the process, the picture is going to look really, really familiar. I'm going to create a bottleneck that, in this case, I have, for example, a factory method that creates that object for me. I'm going to transform all of the original callers to call this bottleneck, and now I can switch from one to the other. Again, I've made that change in small, safe steps. Every single one of those steps was it's obvious. You know, instead of saying new whatever, I'm going to say create me a collection. So that's just one extract method, and you're finished. And then you call it 2 other places, and you're finished. And then you change the implementation, and as long as you have the tests, you can be very confident that that has all gone through just fine. So it's the same process. The picture is the same, even though that code transformation might take a half an hour or 15 minutes. And the kind of data transformations, the data that I was talking about, could take many months to complete. But isolate the change, so you have to make a complicated change in one place instead of multiple places. With code, there's a lot of automated support. So if your IDE supports refactoring, you can make safe changes that if you did them with text editing operations, I would need to run the tests a bunch of times in between. Ioan Padiolu came up with a tool called Spatch, which is a syntactic patch. It takes a syntax tree and transforms it to another syntax tree, which is kind of the assembly language of refactorings. And Spatch is great if you don't have automated refactoring tools available to you. So use the tools if you can to make those transitions go faster. I make a habit of doing the easy transformations first. If I've got 8 call sites that I need to transform, I'm going to go through the ones that are just obviously clear and simple and easy, and I'm going to do all of them first. Because what I learn in doing those transformations is going to teach me what I need to know to do the more complicated ones. I don't necessarily finish. I said this is a 15-minute kind of transformation I was talking about. That's not always true. There are times when I think, oh, I could, code's like this, it should be like that. I get into the middle of it and I realize, oh, it's more complicated than I expected. And at those moments, I'm going to give you a contradictory piece of advice. At those moments, when things get sticky, sometimes the right thing to do is just push a little bit harder. But oftentimes the right thing to do there is to commit and deploy and you'll come back to it later. And after a day's reflection or a weekend doing yard work or whatever, you'll discover that what seemed like it was going to be really complicated turns out, now I figure it out how to do that. When making these kind of code changes, frequent checkpoints are really valuable. If I was about to say something not very responsible. I said, if I could, I would build a git commit into my testing tool, except, I should just do that. So that every time all the tests pass, you just automatically do a commit. So that when you make a change that's just obviously correct and a test breaks, you don't even have to think about it. Let me just try that again. I was sure that would work. It didn't. Let me just immediately get reset hard. I'm back to where I was. Now I'm going to try that transformation again. One other piece of strategy that I use in making code changes is change the interface or the implementation, but never both at the same time. Oftentimes, I'll be making a change, say, to an API, adding a parameter or something. A change, and then I get to this one and I say, oh, this implementation is kind of stinky. I could clean that up. I just write that down on a piece of paper. I always have a card sitting next to my computer, and just say, okay, go fix this implementation later, because I just don't want to get into this, like, where was I? What did I do? So change the interface, then change the implementation. I'm changing the implementation. I see an interface change I want to make. I'll write that down on the card too and get back to it later. Okay, last example. What do you do for systems? And this is the project I'm on now. We have front-end systems. It's a messaging-related project. Front-end systems, who know about web pages and things like that, and HTTP, calling to a system that knows about email messages and threads of messages and authors and recipients and things like that. And it's in this case, it's a proxy that'll go between that front-end code and the back-end code. I hope I'll get a chance to write about it in more detail later. But this is the kind of project I'm working on, where we're replacing calls to one system with calls to another system. The picture's going to be, hopefully at this point, boringly familiar. The first thing you do is encapsulate the access to that other system in one spot. Now, I would have thought that I was capable of... I could look at the situation. Let me go back a second. So here we are. We're calling the system from 3 different places. Immediately I say, hey, I'm a better programmer than that. I'm not going to get in this situation. Except that I do. Some things I'm able to encapsulate up front. Other things I don't notice that, say, knowledge of the old system has... I've moved that several different places to several different callers who know about that old system fairly directly. And so at this point, I think beating myself up further about letting the system get into this state where we're calling something from 3 different places, it doesn't really pay off. So I'm just going to say, well, sometimes that happens when I'm in a situation and I say I need to replace the old system and it's used from one place. Oh, congratulations, good for me, I did that. But if it's called from 3 different places, hey, okay, it happens. I just never imagined that I'd need to replace this, but now I do. The rest of the story by now should be familiar. I'm going to create a bottleneck which just calls the old system initially, so that's a simple thing. Rather than calling the old system, I'm going to call the bottleneck instead. One call site at a time, I'm going to transform them. If I need to do testing, load testing, performance testing, whatever in between each of these individual changes, I can do that. Now everybody's calling the old system, but through this bottleneck, and I can introduce a fork. Now at this point, there's several options. Unlike the case of code, where I used to call this function and now I'll just call that function, systems have complicated behavior. Was working on the performance characteristics of the system that I'm working on earlier today, and I said this is more like gardening than it is like programming. You've got a bunch of inputs, you have a bunch of other things that are changing all the time, and you have a pretty good idea of how the inputs are connected to the outputs, but not really, and some of those connections are nonlinear. And so rather than just switching from the old system to the new system, there's a couple of things that you can do. A common technique is to dark launch the new system. So I'm going to call the old system and the new system at the same time. The dark launch system will not have any permanent side effects, which means that the new system isn't exactly like the old system, which means that the feedback isn't perfect, but you do get some feedback about the performance characteristics of the new system. And you can dial up. Let me send 1/10 of 1% of the messages. Actually, that one of the cool things about Facebook, as I said, is just the ridiculous numbers we deal with every day. And I remember once thinking, well, we could just use 1/10 of 1% of the traffic, and I did the math and realized I still had to handle 1,000 transactions per second, which was pretty cool. But anyway, that's my little brag. So that's the dark launch strategy, or you can divide the traffic. You can call the old system for part of the users and the new system for part of the users. And or you can, if neither have side effects, like for example a privacy check, you can call the old system and the new system and do that compare strategy that I mentioned in the making the data transformations. So there's a bunch of different options for how to make this transition in small safe steps from the old system to the new system. And then eventually the new system's running stable, you're happy with it, and again, you get to pop the champagne corks and have a big party, because shutting off an old system and deleting all the code for it is just such a great feeling. And again, even at these kind of ridiculous scales, you've gotten here in a series of small, safe steps. If the steps aren't safe, make them smaller. That's really the change in mindset that I've tried to teach myself. Part of me, I think there's kind of a masochistic streak that goes through programmers, where you say, oh, I'm making this change and it's going to be really complicated, but that's just what, sometimes is really hard. And learning to become aware of when I get into that kind of mode of thinking and realize, no, it's not like that. It doesn't have to be big, complicated, scary changes. I can make big changes in small, safe steps. And if the steps aren't safe, they're too big. Now, it's an engineering challenge. It's a challenge to my creativity and my skills often to figure out how to take what looks like, I have to do all these things at one time, and to figure out, now if I slice this off and I move this before that, and I change this to here and that to there, that's going to be okay. I'll be able to make this seemingly monolithic change in small, safe steps. Some lessons from systems making these kind of things. The unanticipated, unintended consequences, they're gonna happen if you're working at any kind of scale, and it's all kinds of crazy stuff. And especially combinations of crazy stuff. So this network switches down at the same time that hard disk fails. And we could have handled either one, but we can't handle both at the same time. You have some recovery strategy, except that the recovery strategy uses exactly the same resources that the ongoing system needs to continue serving traffic, and they compete with each other, and so something never gets recovered. It's not the sort of thing that you can really think your way through. There are principles that help you reduce the probabilities of these, but it's never going to go to zero, because in a big system with enough moving parts, every pair of problems that could happen is going to happen, and sooner rather than later. So just learning to live with that has been part of my education, especially at Facebook. I'm used to the code version. The code version is kind of surgical and clean, and it's it's all white, and you go clink clink, and you say this is a semantics preserving transformation. You're absolutely right. Extract, move, bump, 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 and making large changes to systems in small safe steps is just never going to be that way, because your understanding of the system as a whole is never going to be complete. So it doesn't have that kind of surgical quality, even though you can always gain benefit from reducing the size of the steps until they seem like they're really safe. But they'll never be safe in making systems transformations the same way that they are when making code transformations. Again, isolate access to the old system first. Logging is a two-edged sword. You can have so much logging that it begins to interfere with the operation of the system itself. I had a bug like that where I carefully logged some errors, except that meant that the hard disks filled up, which meant that those machines went down, which increased the load on the other machines that were serving the same traffic, which meant that their logs filled up faster, and it doesn't end very well. It ends with me figuring out how to get rid of some of the logging. So I always try and think about what is it that I'm going to wish for when things go bad. Logs are odd. You don't look at logs when everything's going well. Not for debugging purposes. You're looking at them when something has gone wrong. So thinking as a debugger. Hello, Oscar. Thinking as a debugger when I'm writing log statements helps me out. Monitoring is the same kind of thing. You can monitor so much that you saturate the same resources that you're trying to monitor, and then you've got a real problem. But putting monitoring in place early means that you can evaluate the safety of the steps that you take, and it's tempting when the system is so small. You're building this new system and it's just so small, and you're going to call it once and then you're going to throw it away, and putting monitoring in at that moment just seems like overkill. But it's, if you have it and you're used to it, and it's just a habit. I'm just going to, I'll have a screen over here, and it's just going to always show the dashboard for this system, even when the system is tiny, tiny, tiny. Then, as the operation gets more and more complicated, you still have the habit. You're just glancing up, yeah, everything's fine. I made this little change. It couldn't possibly break anything, so I'll deploy it. Oh my goodness, I had no idea. Roll that back. Having rate limits is a valuable way of switching on the new system a little bit at a time. Facebook, we have a very sophisticated system for sending percentages of traffic to through one code path versus another. But even implementing for yourself the simple version of that has some big payoffs. So you can dial up, dial down, down to 0. Where there was a memory leak we didn't expect. The new system really isn't working we thought it was, so just down to 0. Being able to do that quickly, that kind of kill switch, that's just a great feeling. That gives you confidence, which makes you a better engineer, which means that the steps that you choose are going to be safer steps. I have used this dark launch, the idea that you call the new system without any permanent consequences, a little bit in my career, nowhere near as much as I've seen at Facebook. But honestly, I'm a little disenchanted with dark launch as a strategy. I think it has a place, but the place is much smaller than the temptation to use it. Here's the kind of thing that I mean. I am an engineer, and I'm about to make a decision. I think this is a safe step, this transformation I'm about to create. And I think to myself, but there's just that little voice, your nose starts twitching, the spidey sense, whatever your metaphor for this. You're thinking, no, this is fine. Now, that moment is a moment I've learned to pay more attention to, not less. And the problem with dark launch is it gives you an excuse not to stop and think. You think, if it's a problem, it'll show up in the dark launch. And then maybe it does, and maybe it doesn't. Maybe it's a problem that only manifests after 2 weeks, and you only dark launched for a week. Oh, well, let's just dark launch for 2 weeks next time. And that becomes an excuse for less feedback. So from that perspective, I'd say using dark launch as a crutch, and I would rather, if at all possible, be pushing to the live system. If the tests all pass, it just goes to the live system. If I can't do that for some reason, if, for example, there's the possibility of complicated memory leaks that only manifest under conditions of extreme load, then okay, dark launch is a place to shake those sorts of problems out. But it is not a place to shake out problems that if you just had a little bit more discipline, you could say, well, here's this change, and I think so. We'll just dark launch it. If instead you said, here's this change, and how am I going to slice this? Because I know I don't have that back. How am I going to slice this into 2 parts, each of which is really obviously safe? And I crave that moment. And so that's my disenchantment with dark launch. Not that it's not valuable, not that it doesn't have a place, but I don't want it to become a crutch. I don't want it to become a substitute for engineering. A last little tidbit here. This system I'm working on is a proxy. So the protocol of the new system and the old system are exactly the same, and the new system will begin by just calling the old system itself. In that case, the quickest way to start getting feedback was to build the absolute minimum for this proxy that just calls straight through. Whatever was returned gets returned. Now, we're not getting any payoff from having this proxy in between. Not yet. Except that we're in production. We're running real traffic through it. We're forced to go through all the monitoring and alerting kind of systems to make sure that we're awakened in the night if something starts going wrong. And it feels like we have to take every engineering decision that we make seriously, because we know that it's going to be in production in a matter of hours. Because we made this proxy really, really simple at the beginning. Now, once it's in place, we can start doing what we imagine doing for it to make it improve the overall system as a whole. But it's great having the real thing really there, passing real traffic through very quickly. So the recapping what I've just talked about, the overall goal is efficient software development. Put negatively, it's avoiding this limbo of in production, running around unpredictably, unconfident in the system, and busy enough that we can't do further development. We want to be in a position where we're getting feedback about our previous decisions and we're able to make our next decisions right away. That's a nice positive way to look at that. The way to get there, in my experience, is to take a step back and look at this feedback loop. Scope, chaos, time, and say, I'm going to drive that the other way. Doing a better job of getting a bigger, more perfect thing into production just doesn't work. And the bigger and more complicated it is, the less well it works. So I'm going to take that loop and turn it around and drive it the other way. Now those individual steps at first seem really slow, and they probably will be really slow. If you haven't ever deployed more frequently than every 6 months, then deploying every month just seems like, oh, this is crazy. How are we going to do this? It just takes so long. But once you get into the rhythm and you've established the expectation that you're going to get feedback more frequently, then you get good at it. And the steps go quicker and quicker, and the quicker the steps are, the more feedback you get, so the more potential you have for learning. And as I said, I've been looking at this issue in particular, how to make technical decisions that make big changes in big systems in small, safe steps, and I don't think I'm anywhere near the shortest possible cycle. I think that the shrinking of that cycle, what constitutes a safe step, and how quickly those steps can be taken, I'm not going to reach it. It's going to be you guys who figure that out. And probably the people who come after you also will look at the speed of development, the frequency of deployment, and just laugh. Oh, these guys thought that once a day was just crazy. Well, and they're going to go much beyond that. The goal of this is to have development be a long series of just boring, well, of course it works. Well, of course that works. Well, of course that works. Well, of course that works. Is this going to work? I don't know. Which half of it should we do first? Oh, we'll do this half. Well, of course that works. And then every once in a while, because this is the life and the real world, and Murphy's out there, you're going to say, of course this will work, and then it doesn't. And then you got something to learn. And then you'll make your monitoring better, or you'll establish a new direction for your system architecture, and then you're back where you started from, saying, I need to make this big change. How am I going to make it in small, safe steps? I'd like to thank Microsoft for inviting me to present today. I'd like to thank you all for sitting and paying attention here at the end of the day. And the very best of luck to you as you continue to work to improve your skills and do more fantastic things in the world. Thank you very much, and goodbye.